This is a question from IPMAT Indore 2024 paper QA section, and the question is based on permutation and combination, specifically partitioning theory. The question says the number of solutions of the equation is given where x1, x2, x3, x4 are integers with these conditions. x3 and x4, they are more than or equal to 0. x1 and x2, they are more than or equal to 1 and 2 respectively. So we need to find the number of solutions of this equation. So such questions are very easy. We have to have the understanding of partitioning theory. So x3 and x4, they are already more than or equal to 0. Because x1 and x2, they have minimum values as 1 and 2 respectively, we will start from assuming the values of x1 and x2. So what I will say is, let x1 is 1 plus a, right? Because x1 can have a minimum value of 1. So if I assume x1 is 1 plus a, so a can have a value which is more than or equal to 0. Even if a is 0, then x1 will be 1, which is permissible. If a is more than 1, then x1 will be anything more than 1, which is also permissible. Similarly, I can assume x2 as 2 plus b, and by the same logic, b can also be more than or equal to 0. Right? So if we replace these two values of x1 and x2 in this equation, so what do we have? 1 plus a plus 2 plus b plus x3 plus x4, that should be equal to 50. Now this 1 and 2, they can go to the other side. So a plus b plus x3 plus x4, that should be 47. And now the point is, all of them, a, b, x3 and x4, they are all more than or equal to 0. Right? The minimum value of all of them can be 0, and all of them can have any positive value also. So if that is the case, so what we can now think is that we have 47 objects which are to be divided in these 4 groups. Right? These 47 objects are to be divided in these 4 groups such that any group can be empty. Any group can be empty means A can be 0 or B can be 0. A is one group. You can think that there are 4 boxes and we have 47 balls, and we need to distribute these 47 balls in these 4 boxes, and condition is any of the boxes can go empty. So in how many ways can we do that? The number of ways in which we can do that is the number of ways in which, or the number of solutions of this equation. So basically this is the question of partitioning theory. So the basic formula to do that is, when we have to divide n objects into R groups so that any of them can go empty, is n plus r minus 1 c r minus 1, where n is this number, n objects, r is this number, which is 4 in this case. So we can apply this formula directly. So n is 47, r is 4 minus 1, c r minus 1, that is 4 minus 1. So this is 47 plus 3, 50 c3. So we'll have to solve 50 c3 to get to the answer. 50 into 49 into 48 upon 3 into 2. 3 into 2 is 6, 6 into 8 is 48. So what we can do is, 50 into 2 is 100, so I can split this 8 is 2 into 4 into 49. So this is 100, 49 into 4 is 196. 50 into 4 is 200, so 49 into 4 will be 4 less, so 196. So answer is 19600. So answer is 19600. Let us see which is this option. 19600 is option B. So answer is option B.